Welcome back. In front of us, we have a question that reads 50 grams of aluminum rod at 40 degrees Celsius requires 1,800 joules of heat energy to raise its temperature to 80 degrees Celsius. What is the specific heat capacity of aluminum? Solution. We are given that the mass of the aluminum rod is 50 grams. So if we convert that to kilograms by dividing it by 1,000, we have 0.05 kilograms. The initial temperature of the aluminum rod is 40 degrees Celsius, so that is theta 1 is equal to 40 degrees Celsius. The final temperature of the aluminum rod is 80 degrees Celsius, so that is theta 2 is equal to 80 degrees Celsius. In the question, it is stated that 1,800 joules of heat energy was given to the aluminum rod to raise its temperature, so which means that is the quantity of heat, that is Q. So we can say Q is equal to 1,800 joules. Now we want to know the specific heat capacity C. The formula that we have to use is that Q is equal to mc delta theta. So we can say Q is equal to mc delta theta is theta 2 minus theta 1. If we should substitute the values, Q is 1,800 joules. The mass of the object is 0.05 kilograms, multiplied by the specific heat capacity, which we want to know, multiplied by delta theta is theta 2 minus theta 1. The final temperature is 80 minus the initial temperature is 40 degrees. So we'll have 1,800 is equal to 0.05 times C times 80 minus 40 is 40. So that is 1,800 is equal to 0.05 times 40 is 2. So that will be 2 times C is 2C. To find C, we're going to divide both sides by 2. 1,800 divided by 2 is 900. So that is 900 is equal to C. So therefore, we can say C is equal to 900 joules per kilogram per Kelvin. That is the specific heat capacity of aluminum. 300 grams of water at 36 degrees Celsius is supplied with 75.6 kilojoules of thermal energy to raise its temperature to 96 degrees Celsius. What is the specific heat capacity of water? Solution. The mass of water given in the question is 300 grams. If you convert that to kilograms by dividing it by 1,000, you get 0.3 kilograms. The quantity of heat given in the question is 75.6 kilojoules. So to convert that to joules, we multiply it by 1,000 because 1 kilojoule is equal to 1,000 joules. So 75.6 multiplied by 1,000, that is 75,600 joules. Now the initial temperature given is 36 degrees Celsius and the final temperature given is 96 degrees Celsius. We want to know the specific heat capacity of water. The formula we're going to use is that the quantity of heat is equal to mc delta theta, but we know that delta theta is going to be theta 2 minus theta 1. So by substituting the values that we have, Q is 75,600. This is equal to, the mass is 0.3 kilograms multiply it by the specific heat capacity of water is C, multiply it by theta 2 is 96 degrees minus theta 1 is 36 degrees. So that will be 75,600 is equal to 0.3 times C times 96 minus 36 is 60. So we will have 75,600 is equal to 0.3 times 60 is 18. So that will be 18C. To find C, we divide both sides by 18. So this will cancel this. Therefore, the specific heat capacity of water is equal to 75,600 divided by 18. That will be 4,200 joules per kilogram per Kelvin, or if you like, you can say joules per kilogram per degree Celsius. The temperature of an iron bar of mass 400 grams rises from 20 degrees Celsius to 60 degrees Celsius when 7,200 joules of heat is supplied to it. Calculate the heat capacity of the iron bar, the specific heat capacity of the iron bar. Solution: the mass of the iron bar is 400 grams, which is the same as 0.4 kilograms. The initial temperature of the iron bar is 20 degrees Celsius. The final temperature of the iron bar is 60 degrees Celsius. The quantity of heat supplied is 7,200 joules. So we want to find the heat capacity and the specific heat capacity. Now, for question 1, we can use the formula: the quantity of heat is equal to the heat capacity multiplied by delta theta, that is change in temperature. Okay, so that is, we can say the quantity of heat is equal to the heat capacity multiplied by theta 2 minus theta 1. So what is the quantity of heat? It is 7,200 joules. This is equal to the heat capacity multiplied by the final temperature is 60 minus the initial temperature is 20. So that is 7,200 is equal to C multiplied by 60 minus 20 is 40. So we have 7,200 is equal to 40C. To find C, which is the heat capacity, we divide both sides by 40. So this will cancel this. 7,200 divided by 40 is 180. That is equal to C. So we can say C, which is the heat capacity, is equal to 180 joules per Kelvin, or if we want, we can say joules per degree Celsius. So to find the specific heat capacity, we can use the formula C is equal to mc, or we can use Q is equal to mc delta theta. All right, any of them will work. So going by C is equal to mc, that is the heat capacity is equal to the mass times the specific heat capacity. What is the heat capacity? We have calculated it as 180. This is equal to the mass of the object is 0.4 kilograms. So that will be 0.4 multiplied by C. That is 180 is equal to 0.4 C. To find C, we divide both sides by 0.4. That is 0.4 will cancel. So we can say, therefore, C is equal to 180 divided by 0.4 is 450 joules per kilogram per Kelvin. Okay, that is the specific heat capacity. Alternatively, if we want to use the other formula, Q is equal to mc delta theta. Q is given in the question, that is the quantity of heat, which is given as 7,200 joules. So we can say 7,200 is equal to, the mass is 0.4 multiplied by the specific capacity multiplied by the delta theta will be theta 2 minus theta 1, and theta 2 is 60 minus theta 1 is 20. So that is 7,200 is equal to 0.4 times the specific heat capacity times 40. So that will be 7,200 is equal to 0.4 times 40 is 16. So that will be 16C. To find C, we divide both sides by 16. Okay, so this will cancel this. Therefore, C, which is the specific heat capacity, is going to be 7,200 divided by 16, which will still be 450 joules per kilogram per Kelvin. Okay, so as you can see, you can use different formulae to find the specific heat capacity. All right. The temperature of a piece of copper of mass 800 grams rises from 20 degrees Celsius to 80 degrees Celsius when a heater operating at 77 watts is used to supply heat to it for 4 minutes. Calculate the heat capacity of copper, the specific heat capacity of copper. Solution: we are given that the mass of copper is 800 grams, so that is 0.8 kilograms. The initial temperature, theta 1, is 20 degrees Celsius. The final temperature is 80 degrees Celsius. The power given in the question is 77 watts, and the time taken for the temperature to change from 20 degrees Celsius to 80 degrees Celsius is 4 minutes. So with these values, we want to find the heat capacity and the specific heat capacity. You want to know the heat capacity and the specific heat capacity. Okay? Now, time is given in minutes. We can convert it to seconds by multiplying it by 60. So 4 times 60 is 240. So that will be 240 seconds. Whenever you are given power or current or voltage, you should always have in mind that you can find the quantity of heat by either using the quantity of heat is equal to power multiplied by time, or the quantity of heat is equal to the current times the voltage times the time. But in this question, we are given power and time, so which means the first equation will work. Let's first try to find the quantity of heat, then we can be able to solve for heat capacity and the specific heat capacity. So using Q is equal to PT, that is the power times the time. The power given in the question is 77 watts. Multiply it by the time is 240 seconds. So 77 times 240 is 18,480 joules. So which means this was the amount of heat that is supplied to the piece of copper. Okay. So now I will move on to answer question 1, which asks us to find the heat capacity. We know that the quantity of heat is equal to the heat capacity multiplied by the change in temperature, delta theta. So we can say the quantity of heat is equal to the heat capacity multiplied by theta 2 minus theta 1. We have calculated the quantity of heat as 18,480 joules. So this is equal to the heat capacity, multiply it by the final temperature is 80 degrees Celsius and the initial temperature is 20 degrees Celsius. So that will be theta 2 is 80 minus theta 1 is 20. So that is 18,480 is equal to C times 80 minus 20 is 60. So that is 18,480 is equal to 60 C. To find C, we divide both sides by 60. So with that, this will cancel this. Therefore, we can say the heat capacity is equal to 18,480 divided by 60, and that will be 308 joules per degree Celsius. Or if you like, you can say per Kelvin. So moving on to the second question, I can use the heat capacity is equal to the mass times the specific heat capacity to be able to find the specific heat capacity. The heat capacity is 308 joules per degree Celsius. So this is equal to the mass given in the question is 0.8 kilograms. So that will be 0.8 times C. 308 is equal to 0.8 C. To find C, we divide both sides by 0.8. That is, this will cancel this. So we can say the specific heat capacity is equal to 308 divided by 0.8 will be 385. So that will be joules per kilogram per degrees Celsius. Okay, but alternatively, we can be able to use the formula Q is equal to MC delta theta, where delta theta is going to be theta 2 minus theta 1. So when we use this formula, we can still be able to find the specific heat capacity. All right, we know that the quantity of heat is calculated as 18,480 joules. So by using that, 18,480 is equal to the mass of the object is 0.8 kilograms multiplied by C multiplied by theta 2 minus theta 1 is going to be 80 minus 20, right? Theta 2 is 80 degrees, theta 1 is 20 degrees. So we're going to have 80 minus 20. That is 18,480 is equal to 0.8 times C times 60. So 18,480 is equal to 0.8 times 60 is 48. So that will be 48 C. To find C, we have to divide both sides by 48. So this will cancel this. Therefore, C is equal to 18,480 divided by 48. And we're still going to have 385 joules per kilogram per degrees Celsius as the specific heat capacity. Okay? An electric heater operating from 230 volts main supply is used to heat water of volume 690 centimeter cube from 36 degrees Celsius to 76 degrees Celsius in 1.68 minutes. Calculate the current and the resistance in the heater. The specific heat capacity of water is given as 4,200 joules per kilogram per Kelvin, and the density of water is given as 1,000 kilograms per meter cube. Solution: we are given the voltage as 230 volts. So the voltage is 230 volts. The initial temperature is 36 degrees Celsius. The final temperature is 76 degrees Celsius. The time is 1.68 minutes. The specific heat capacity of water is given as 4,200 joules per kilogram per Kelvin. And the density of water is given as 1,000 kilograms per meter cube. So we want to find the current and the resistance. What is important to note is whenever you are dealing with problems of heat that involves electricity, you have to know that the quantity of heat is equal to power times the time, or the quantity of heat is equal to current times voltage times the time. So you should always try to remember these formulae. So what we have to try to do is to find a way to calculate the quantity of heat. Okay, we can be able to find the quantity of heat from this problem if we use MC delta theta. All right, let's do that first. The quantity of heat is equal to MC delta theta. We can be able to find the mass because we know the density and the volume is given in the question. All right, the volume given in the question is 690 centimeter cube. So let's try to write that one also. Volume is equal to 690 centimeter cube. So when volume and density is given, mass can be calculated. So what I will first try to do is to calculate the mass of the water here. I have to convert volume that is in centimeter cube to meter cube. I know that 100 centimeters is equal to 1 meter, but since we are dealing with cube, if I cube both sides, that is 100 centimeter cube will be equal to 1 meter cube. So what is 100 cube? That is going to be 1 million. So 1 million centimeter cube is equal to 1 meter cube. You see that? So if 1 million centimeter cube is equal to 1 meter cube, what is 690 centimeter cube? That will be equal to x. So what I have to do is to cross multiply, and if I cross multiply, that will be x times 1 million centimeter cube is equal to 1 meter cube multiplied by 690 centimeter cube. So because I just want to know x, I can divide both sides by 1 million centimeter cube. Okay, so this will cancel this. Centimeter cube cancel centimeter cube. So we are now left with just meter cube here. So that is x is equal to 690 times 1 meter cube is 690 meter cube divided by 1 million. If I do that, I will have x as 6.9 times 10 to the power negative 4 meter cube. That is, the volume is in standard form. Okay, so I know that when I use density is equal to mass divided by volume. If I want to find mass, mass is equal to density times volume. So the density is given in the question as 1000 kilograms per meter cube. So that will be multiplied by the volume in meter cube is 6.9 times 10 to the power negative 4 meter cubed. When you do that calculation, 1000 times 6.9 times 10 to the power negative 4, we will have 0.69 kilograms. So which means this was the mass of water that we are dealing with. Okay, so we can now use this formula Q is equal to mc delta theta to find the quantity of heat first. So that is going to be, the mass is 0.69 times the specific heat capacity of water is 4200 times delta theta will be theta 2 minus theta 1. Theta 2 is 76 degrees Celsius minus theta 1 is 36 degrees Celsius. So that will be 0.69 times 4200 times 76 minus 36 is 40. So 0.69 times 4200 times 40, we will have 115,920 joules. So that is the quantity of heat. So how can I use that to find the current? We know that the quantity of heat is also equal to IVT. That is the current times voltage times the time. So the quantity of heat is 1,115,920 joules. This is equal to the current times the voltage is given as 230 in the question times the time given in the question is 1.68 minutes. So if we multiply that by 60, we will get 100.8 because we have to convert it to seconds. Okay, so time is 100.8 seconds. Going back, so the time is 100.8 seconds. We will have 115,920 is equal to the current times 230 times 100.8. That will be 23.184. To find I, which is the current, I will divide both sides by 23.184. 23.184. So this will cancel this. 115,920 divided by 23.184, that is 5. So that is equal to I. So therefore we can say the current is equal to 5.0 amps. The second question asks us to find the resistance. We can use V is equal to IR. That is, the voltage is equal to the current times the resistance. The voltage is 230 volts. This is equal to I is 5.0 amps multiplied by resistance. So to find the resistance, we divide both sides by 5. This will cancel this. So therefore, the resistance is equal to 230 divided by 5. That is 46 ohms. That is all for today. Thank you very much for watching this video. Please subscribe to the channel, like and share our videos.